Okay. Hi, welcome to another episode of PSDtv. I'm your host, Alix Paultre, and today I've got notable engineering legend, Bob Dobkin of Linear Technology. I'm very lucky to catch him at the Electronica Show. Thanks, I really appreciate you being here.
I'm happy to be here, and I'm still working full-time.
That's one of the things we all love about you, Bob. I mean, when you think about the innovations, the technology, I mean, there's a lot of news that's not technology about linear right now, but I like to remind our audience about some of the things you are doing and some of the beautiful advances that have come out of your shop.
That's an application advance. We also have advances in the ICs themselves.
Oh yeah, so tell us about some of that.
Yeah, our battery management ICs. We have a whole string of battery management ICs going up to 100 volts for 18 cells. And the way we architected our battery management chips, it's actually two chips in the package. One is a subsurface zener to give really good long-term stability and low noise to the reference. It's better than we can get with band gaps. And we continue to push for stability and long-term stability in our battery management chips.
Wow, that's really important. Well, obviously, battery safety is in everybody's mind right now.
Battery safety is in everybody's mind, yes.
Now, what about the rest of the automobile? For example, I'm going to bother Dave about that a little bit later, but your new system here could actually be used as a redundancy for all CAN systems in a car, correct?
Yes, it'll supply, be redundant for CAN system. It's got a bandwidth limitation. The CAN system can carry a megabit. This is much lower, but it's certainly good enough to do a lot of the systems. It'll keep a lot of the systems running and give data. It also, because it's wireless, you can get the data out somewhere else. So you can pull into a garage and find out the status of the cars without any connection to them.
Well, you know, any kind of wireless monitoring system has got to have multiple advantages.
It's got multiple advantages. One, you can get the data out. Two, connectors are notoriously unreliable. There's no connectors to fall apart. Power level is low enough that you don't have to worry about it. And many customers like the fact that when we take a piece of data or get some data in, we timestamp it. So they have very accurate timestamp on it, which is what they need in a battery system. They want the voltage and current simultaneously.
And thermal.
And thermal. Thermal is slow, so we don't need to really timestamp that. Nothing changes fast in thermal systems.
Good point. That's a very good point. But you do monitor the thermal.
We monitor the thermal as well, yes.
Excellent, excellent. Now, what about outside of the car? What other innovations have you gotten for, say, the board level?
We're continuing to push our regulator applications and our data converter applications. Regulators are going higher in power. They switch faster. One of the curves here shows the efficiency drop-off with switching frequency, and our regulators have much lower drop-off of efficiency as you go faster. And that's a result of very careful device design and circuit design in the switching regulator to keep all the transient switching fast and not interfering with each other. We have what we introduced last year, a silent switcher. Silent switcher cuts the EMI by 20 dB, but one of the interesting things is if you're radiating EMI, you're losing power.
Yes.
So it improves the efficiency as well.
Well, waste not, want not, right?
Right. We keep the energy to ourselves.
That's a good one. Now, with all of this, can you say anything about the future? Because obviously, as I mentioned, there was a little bit of non-technical. What's going on now with linear going forward?
I think in power, we're going to go forward and we're going to go to higher powers at high switching frequency. So it stays small, but we can go to 20 or 40 amps with some of our switchers.
Very nice.
Power. Yes.
Very nice. Well, now, and then you had mentioned wide bandgap a little earlier. Do you have any plans to really get heavily into that? Or are you going to still flirt with it if it's necessary? But
there's one part that'll use a wide bandgap. I'm not ready to talk about that.
Understood.
But most of the wide bandgap is gallium nitride, and they're putting that down on silicon chips. We're not going there yet. It's probably best for high voltage, and up to voltages of 100 volts, silicon is just fine.
Excellent point, Bob. Very good point. Is there anything you'd like to leave our audience with before we finish up?
We're still pushing for better analog circuits. We keep wanting to do better than we did before. I think when we made plans for analog circuits that we were coming out with, we'd look at the competition and we'd say, we have to be better than them. We're going to be part of analog devices. Now it's going to be, we have to be better than the other group in analog devices.
Well, you're going to obviously be a very strong part of analog devices. They need your IP.
Yeah, the analog devices likes our power management circuits and our power. They have a very small power. We like their data converters. And it looks like they're going to have the higher frequency communication data converters. We'll do the industrial ones. But so far, nothing is settled.
Understood, Bob. But I really appreciate you taking the time at this very busy show to talk to us.
Okay. Thank you.
Thank you.
Good to see you again.
It's always good to see you, Bob. And I'd like to thank everybody out there in the audience for taking the time to be with us. We wouldn't be here without you. Tell your friends. This is Alix Paultre for Power Systems Design. Have a great day.